Okay, so basically the sum of the interior angles of a triangle are what? 180. All right, what are the sum of the interior angles of a quadrilateral? 360. Why is that? That's exactly correct. Thank you very much. All right. The reason is because when you draw a quadrilateral, all you're doing is dividing it into two triangles. All right. So that's how he knew the angles here were 180, the angles here are 180, so they add up to 360. All right. Now we talked about the triangle already being 180 degrees. So now, what do you call something that's five-sided? Pentagon. So what are the interior angles of a pentagon going to be? Uh-huh. 540. Why is that? Because you're going to divide the pentagon into what? 3 triangles. Everybody see that? And so each triangle adds up to what? 180. All right, so that's 540 degrees. All right, and obviously we could continue the pattern here and say now I have how many sides here? 6. So that's called a what? So how many degrees in the hexagon? 720. All right, now once again, all you're doing is you are taking the hexagon and dividing it into triangles. How many triangles are there? 4. So that would be 4 times 180, which is 720 degrees. All right, so that's how simple this unit is. All right, the sum of the interior angles of a polygon, and it has to be termed convex polygon, all right, is n minus 2 times 180. That's the formula. All right, now what does n represent? The number of sides. All right, now why do we multiply by 180? Because that's the interior angles of a what? What does n minus 2 represent? How many triangles that can be formed from the polygon? That's exactly right. All right, that's how simple it is. All right, and again, I always tell everybody, it's not necessary really to memorize that. If you ever have trouble, just draw a polygon and cut it into triangles, and then you can quickly establish the relationship. All right. Now, those are the interior angles. All right, now there are exterior angles. All right, so what I want to do is I want to try to draw this out for you. All right, and I'll just draw this shape right here. All right, pentagon here. Now it's kind of unique because, all right, if I were to draw an exterior angle, this is considered an exterior angle. Then this would be considered a what? Exterior angle. Then this would be considered a what? Then this would be considered a what? And then this would be considered a what? Exterior angle. So there are how many exterior angles? That's what I had thought. I always said there should be 10, right? Why is that? Because I could also draw over here, correct? I could draw that one. Well, this one over here, this one over here, and this over here. So you're just extending it. Does everybody see that? So I argued with my teacher. I said it was obviously 10. All right. But how many interior angles are there? There are 5. So I believe that's why they said, no, there's not 10. There's what? 5. Because how many interior angles are there? 5. So there must be what? 5 exterior angles. And so I guess the theory was this exterior angle is exactly the same as what? That exterior angle. Is everybody okay with that? All right. So the exterior angle has a property similar to the n minus 2 times 180, but it's a lot easier. If I were actually to measure all of these angles, all of the exterior angles, they would guess what? They would add up to what? 180 degrees. Or I'm sorry, not 180, but 360. All right. So the exterior angles always total 360 degrees. All right. They always total 360 degrees. Just like the angles of a triangle, they always add up to what? 180. All right. So those are basically the rules for today. Now, let's talk about why it's called convex. And then the other one, does everybody know what the other one's called? Convex and what? Concave. That is correct. So here is something that is considered convex. And the reason why they call it convex, the formal definition is whenever I draw a diagonal, the diagonal is on the interior. All right, is on the interior. But if I draw something that's concave, when I try to draw all the diagonals, a diagonal will end up where? On the exterior of the polygon. All right, so that's what convex and concave. Convex means all of the diagonals are on the interior. Concave means that a diagonal, which is just a segment drawn from two non-consecutive vertices, that creates a diagonal. So this diagonal is on the exterior, whereas all of these diagonals will be on the interior. All right. Now, of course, the easiest way I do is just say, well, this kind of looks like a cave to me. So I knew that was concave. All right. Anybody have any objections to that? All right. So with that being said, all right, find the sum of the measures of the interior angles of each convex polygon. All right. So what is the formula for that again? N minus 2 times 180. All right, so now everybody take out your handy dandy calculator. Let me show you something kind of cool, because I don't feel like doing all the arithmetic here. Everybody go to Y1 and type in 180 x minus 2. Everybody with me? Everybody okay with that? Okay, so now that you've typed that into Y1, now go to your table, second table. And now, how many sides does a decagon have? 10, right? So now just type in 10. And what's the answer? 1,000 what? 1440 degrees. And then the next one, we're going to plug in what? 16. All right, how many degrees in a 16 gon? 2,520 degrees. Is that nice?
Yes.
All right, that's a nice way of doing that. All right. And someone help me for a 30 gon. How much? 5,040 degrees. At least you not have your calculator, kiddo. What about you? You got to bring them every day, man. We're going to use them every day. All right, just get in the habit. Just put them in your backpack. Octagon. What do we got for an octagon? 1,080. And for a 12 gon, 1,800. And for a 35 gon, 5,000 what? 5,940 degrees. Anybody have any issues with that? All right, so that's a kind of a nice way of doing that. All right. Now, someone please tell me what a regular polygon means. regular polygon.
All the angles are the same.
And all of the, yes, all the angles and all the sides are the same. Kind of like a square. All right. A square is considered a regular polygon. You okay?
Where do you go to first table?
Did you get to the table?
No.
You press second table.
Yeah.
No, you said you plugged in table set.
And then you type in how you want to show it.
Yeah, she was in table set. She wasn't in table. Okay. So again, that was good, Jackson. Say again what a regular polygon is.
All angles and sides are the same.
All angles and sides are the same. So if we were looking at my pictures up here, this one right here is a regular pentagon. All right, because all the sides and all the angles are the same. This over here is not regular. All right, because the sides are not the same, and the angles are not the same. So everybody agree with that? All right, so now let's see how many of you are thinking. All right, well, I'm not there yet. I'm sorry. The measure of an interior angle is given as 150 degrees. So how do we calculate the number of sides that it has? Yes.
How many times 150 goes into 360?
Now, that's an interior angle though, not an exterior. So again, the formula, right, for the sum, everybody look at this. The sum is equal to n minus 2 times what? 180. If it's regular, what's true about all of the angles? They're the same. So if I wanted to find the measure of each angle, what would I do to that formula? The interior angle would equal n minus 2 times 180, and then I would divide it by what? No. No. This is the sum formula. I want to know each interior angle. Each interior angle will be n minus 2 times 180 divided by what? Divided by what? Divided by the number of angles, right? Right, if this, come on now, again, I think it's kind of logical, but you got to tell me, this represents the sum of all of the angles, correct? And all of the angles are equal, correct? If it's regular. So if I divide it by the number of side or the number of angles, that will tell me what each angle measures. Everybody good with that? Everybody okay? So now they're telling me that each angle is 150 degrees. So if each angle is 150 degrees, it would be 150 is equal to n minus 2 times 180 divided by n. So that's just a little algebra problem. So how do I get rid of divided by n? Multiply by n. So I have 150n equals 180n minus 360. Everybody see that? So does everybody agree I have 30n is equal to 360? So how many sides did this have? How many? How many? 12 sides. Wow, you guys are sound asleep today. 12. Is everybody okay with that? All right, just for practice, let's say each angle was 160 degrees. So somebody tell me if the interior angle is 160 degrees, how many sides is that?
18.
Somebody said 18. Whoever said 18, good job. All right, now don't do anything more because I want to show you something. I want to show you a shortcut to that. What?
How did you get, minus 360?
All right. So what I want to do is I want to try to draw a regular. Here we go. Everybody's looking at this real quick. All right, just so I can show you. All right. Now, the sum of the exterior angles is what? Does everybody agree? The sum of the exterior angles is 360. So if you don't know that, again, that's something we just talked about. Some of the exterior angles is always 360. So when everybody to just, and again, if you don't want to write it down, that's fine. This is an exterior angle over here. This is a what? Interior. What's true about an interior and an exterior? They're supplementary. Exactly. They're supplementary. Does everybody agree with that? So if I had a pentagon, somebody tell me a regular pentagon, what's the exterior angle going to be? What's the measure of the exterior angle? But you don't have to know, just tell me how to find it.
You just subtract the.
Stop. Nope. What's the sum of the exterior angles? How many exterior angles are there? They're all equal. Divide by 5, right? Does that make sense? 360 divided by 5. Is everybody okay with that? So that's how many degrees? 72 degrees, right? So what's the interior angle going to be? 108. All right, is everybody with me? So if I know the interior angle, can I find the exterior angle? So if I have the exterior angle, how do I find the number of sides? Yeah, I was always puzzled by people who had trouble with this. All right, I think it should be logical. What? And then how do I find the number of sides? Tell me, James, what do I do?
So divide 360 divided by 72.
Yes, exactly. All right, so 360 is the sum of the exterior angles, right? So if I take 360 and divide it by the number of sides, that will give me the exterior angle. Now, please follow along with this because, again, I know it's challenging because every year I say it's easy and then kids look at me like I'm crazy. So does everybody understand 360 divided by the number of sides gives me the exterior angle, right? Now, watch what I'm going to do, and you tell me if you agree with this. Is that still true? Does everybody agree with that? Now, if I go back to the way it was, I could just come over here and say 360 is always the exterior angle times the number of sides. Great. Everybody okay with that? So 360 divided by the number of sides will give me the exterior angle. And 360 divided by the exterior angle will give me the number of sides. Now, come on. The reason why I'm showing you this is because I'm trying to make your life up here simple. Because there is no way I feel like doing this a bunch of times. Does everybody agree with me? I just don't feel like doing that. All right. So if you understand the relationship between the interior and the exterior, the problem is going to be simple. All right. That's how I knew whoever said 12 was correct. All right. Just like over here, 160, I know the answer is 18. How do I know the answer is 18? Because in my head, I just did 360 divided by 20. And that's 18. Why is that? Somebody tell me why that is. What does 20 represent? The exterior angle, correct? Because the interior angle is what? 160. Does everybody agree with that? And then what did I do? 360 divided by the exterior angle, that's going to tell me the number of sides. Right now, I just am telling you a whole bunch of formulas, but to me, the formulas, if I know the sum of the exterior angles is always 360, and someone tells me it's regular, I just divide 360 divided by n. That tells me what the exterior angle is, right?
Mhm.
Okay, so the reason I'm saying this over and over is because I would prefer that you understand it, not write all the formulas out. And if you don't understand what I'm saying, it'd be nice to ask. What?
How confused I got from 360 to, 160 to 20.
Okay. So this represents the interior angle. Do you agree?
Yeah.
Right. So if that represents the measure of the interior angles, then the exterior angle would be what?
Oh, okay.
Right? Because we have over here my picture that's not very good, but it's trying to demonstrate what? That an interior and an exterior is always what?
Supplementary.
It's always supplementary.
Okay.
Does that make sense, guys? Anybody else have any questions with that? All right, because really and truly, this really is super quick, super easy, especially with a calculator. All right. So to me, number 9,
72.
why?
Because 360 divided by 5.
360 divided by 5 equals 72 sides. That's exactly correct. Anybody have any issues or anybody having trouble understanding that? Now, of course, if you want, you can say 175 is equal to n minus 2 times 180 divided by n. Well, you get the same thing. You get the same thing. All right. Because we want to get our work done. Number 10, n equals what? 24. Anybody have any problems? N equals 24. All right. Number 11, n equals 10. Remember, n stands for the number of sides or the number of angles. All right. So 12. How much? 8. All right. So that was a good lesson. All right. So now let's talk about find the value of x. Is this regular?
No.
No, it's not regular. So what do the angle measures add up to?
720.
Why is that? I'm not saying you're wrong.
Five sides, you get 2 sides.
That's right. You're 100% right. So 3 times 180 is 540.
So 540.
Yeah, I know. That was good though. You know what you're doing. 540. Everybody okay with that? And then 540. Now, again, this is mental math. Add up the x's for me and tell me what that is.
20
Somebody said 28x, and then what?
plus 1.
Plus 20 equals 540. And again, I really don't care if you use a calculator, right? Some of you do, some of you don't. So x is what?
18.97.
Ooh, is that correct?
26. Yeah.
Is it what?
26.
Oh, thanks for whoever can't count. 26x. Thank you. James, you all right with that?
Yeah.
I know the feeling. All right, so what's x?
20.
Everybody okay with that being 20? Now, they just want to know what x is, but they might have asked, what are the angles? All right, so keep that in mind. Okay, number 14. Find the sum of the measure of the exterior angles of each convex polygon. Help me, guys. 14, 15, 16. What are those answers? What?
14 is 36.
14 is 36. Anybody agree with that garbage?
Yeah.
Tell us. What? Someone tell me the answers for 14, 15, and 16. Tell us. How much? Wow, somebody who's actually paying attention. One person. Thank you very much. Jackson, you get the award for the day. You get the math award. All right. What are you saying 360 degrees for?
Because all of the exterior angles add up to 360. no matter what.
Always, no matter what the shape is, the exterior angles will always add up to 360. Is that true for the interior angles? No, there is no such rule. So 360, 360, 360. Everybody good with that? Anybody have any issues? All right, so here we go. Find the measure of each exterior angle for each regular polygon. Now we do what? Divide, right? So somebody help me with number 17. 30. All right, now we're going to write 30 degrees just to make sure. So if that's 30 degrees, then what's the interior angle? 150. Just making, you see that. All right, so help me out with 18. What's a hexagon? 6. So what's the answer? 60 degrees. And 19. How many? 18 degrees. 20.
90,
How much?
9.
9 degrees. Thank you. Uh-oh, heptagon. Who remembers what a heptagon is? 7 sides, right? Does that divide evenly? So 360 divided by 7 degrees. All right, if you want to say 51 and 2/7, I don't care, but I prefer 360 divided by 7. All right, what about a 12 gon? 30 degrees. What about a 24 gon?
15.
And what about a dodecagon? How much is a dodecagon? 12. That's right. So 30 degrees. And octagon. 8 sides. So that would be how many? 45 degrees. I'm pretty good with that. I told you guys it's so simple. All right, so simple. All right, it's going to get a little harder tomorrow. So, all right, don't worry about it. Find the measure of each interior angle. So now this is the one that's kind of annoying because they want what?
Each measure.
Yeah, each measure. All right. So what do the angles add up to here, guys? So how many x's do I have? 6x minus 30 equals how much? 360. So what does x equal? How much? 65. X is 65. All right. So now off to the side, 65 degrees, 65 degrees. And now these are both the same, 2x minus 15. So then that would be, I think, 115. Anybody else get that? And 115 degrees. You can just write it like that if you want. That's perfectly fine. Okay, 27 is pretty much the same. 28 is the same. All right, let's look at 29. What are we thinking on 29? The sum is how much? 720 is equal to what? How much? 36x, someone said. I don't believe her, but somebody else double check that, please. So x equals 20. All right. So now I just got to go around and put down 140 degrees, 140 degrees, 80 degrees, 140 degrees. Okay. Okay, so now, who cares? This is a regular octagon, right? So how do I figure out, what's the quickest way to figure out what the octagon is? Well, to me, it was always the exterior angle. I could find the exterior angle easily, right? So what's the exterior angle?
360 divided by
Well, we already did that up here for those of you guys, right? What's 360 divided by 8?
45.
45 degrees. So the exterior angle is 45 degrees, which means the interior angle is what? Yes, 135 degrees is your answer. All right. Anybody have any issues with that? Let's see if someone can tell me, figure out what the measure of angle 1 is, please. What's the measure of angle 1? How much?
Oh, no. 150.
Somebody said 150. Anybody else agree with that? Come on now, remember, the little bit harder now, all right? Problems are a little bit harder. All right, so you got to think a little bit. So please tell me how you did that. I'm not saying you're right, but just tell me what you did.
I still like to read it on the offline.
No, just tell me.
I did 360 divided by 12. And then I subtracted 180 by 30.
360 divided by 12, right? And that was how much?
30
30 degrees. So that's the what?
exterior.
That's the exterior angle.
And then I did
So if I was drawing this right here, guys, this is what I'm trying to show you. I want to show you, if I were to draw that, well, let me do a better job. So if I start here and I extend this out, this right here is how many degrees? 30 degrees. Does everybody agree? So now what?
Oh, and then I just did 180 minus 30.
So 180 minus, so this angle right here, I agree with you, is 150 degrees. So are you telling me that's the same as the other guy?
No. Oh.
Not a bad thought. Come on, someone else help me out. I'm listening.
Is it 120?
Why 120?
Because it says that those two angles on the left and on the right are 90. And it's I counted and I think it's a heptagon. So the sides or the angles add up to 900, right? And then it says those angles on the left or right are right angles, so they're 90. And then you just said that that angle is 150, and then there's 3 more of those, so those equal 600, and then 180 plus 600 equals 780, and then the last one is 120.
Come on, guys.
What the,
No. What did you say?
what the?
Be careful. You've already gotten in trouble once. So I'm saying join instead of being marveled. Wow. I think that's correct. How many sides are on this? How many sides is this stage? Well, I like to not count sides, but vertices. 1, 2, 3, 4, 5, 6, 7. Does everybody agree with that? So 7, right? So the angles here are 7 minus 2 times what? 180, right? So how much is that again? 900 degrees. So all of the angles add up to what? 900 degrees. That's very good. All right, very good. How many 150s are there? So that's 600, right? And then 90 and 90, 180. So that gives me 780 degrees. So after all that, it is what? 120 degrees. Very good. Yes. How many angles? What is the sum of the interior angles? And how many angles have we accounted for? Right, and what do those angles add up to? So. All right, there we go. All right, 31. All right, let's try 34. Before it was on Earth, they knew from ancient texts that the castle was shaped like a regular polygon, but nobody knew how many sides it had. Some said 6, others said 8, and some even said 100. From the information in the figure, how many sides did the castle really have?
15.
Somebody said 15. Everybody's with me on 15, right?
360.
Right, because the exterior angle of the wall is what? Yeah, 24. Is everybody okay with that now? All right. 360 divided by 24 is 15 sides. All right, I'm pretty happy with that. Okay, so I'm going to let you try to figure out 35 on your own. All right, I want to find all the missing angles there. 1, 2, 3, 4, 5. All right, and then go back, make sure you know 28, make sure you know 27. And I think I did everything else, correct? All right. I think that was pretty good.